Welcome back. Let us go through the question. Uh, a tank with a square base of area 1 meter square. It is divided by a vertical partition in the middle. The bottom of the partition has a small hinge door of area 20 centimeters square. The tank is filled with water in one compartment and an acid of relative density 1.7 in the other, both to a height of 4 meter. Compute the force necessary to keep the door closed. So the pressure in the water side at the bottom is Pw, which is equal to rho WGH. If we put in the values, we get the value of Pw to be 3.92 into 10 to the power 4. Now pressure in the acid side at the bottom is given by the same formula. Now if we put in these values, we get it to be P.664 into 10 to the power 4. So we need to find out the difference of the pressure across the door, which is given by this particular formula, which is PA minus PW. These two values, right? So if we compute that, we get the pressure difference to be equal to 2.774 into 10 to the power 4 Pascal. Now area at the door is 20 centimeters square. So the force necessary to keep the door closed is given by this particular formula, which is this area into the difference in pressure, which we have calculated already. So if we put in these values, we get the force to be equal to 54.88 Newton. One thing is to be noticed here, which is the dimensions of the door are small enough to neglect pressure variations near it.